Welcome to the lecture series on soft computing in computer science. This lecture is the continuation of application of physiologic systems and it is part 2. In this lecture, we are going to see about how aircraft landing system is designed using physiologic and how an inverted pendulum is designed using physiologic. Let me take the first one, aircraft landing using physiologic control. So, what is aircraft landing? Aircraft landing is one of the most critical phases of flight that demands precision and careful control to ensure safety. Traditional control methods such as proportional integral derivative controllers, shortly called as PID controller, it is very complex to design and may not handle the uncertainties and non-linearities of the real world environment effectively. So, if you apply this traditional control system, that is PID controller, you cannot realize what exactly the needed based on the external environment when you are about to land a aircraft. So, the aircraft landing has been effectively designed based on the external environmental factors that contains lot of uncertainties. It is not a simply a 0-1 game, and it should be very effectively designed and planned. So, here we come to apply the idea of a fuzzy logic, because this fuzzy logic mimics the human decision making and it is always treated as an alternative approach whenever the environment or the data or the problem statement contains vagueness and some imprecision that has been inherent in the system. Particularly, the aircraft landing system has lot of vagueness and imprecision. Let us see how this aircraft landing system can be designed using fuzzy logic. First of all, let us discuss about the problem associated with aircraft landing. In an aircraft landing scenario, several factors must be controlled simultaneously to ensure a smooth and safe descent, right. So, then only we may treat that as the aircraft landing is a safer one. So, what are the factors? The factors are altitude, speed and distance to the runway. So, these are the three factors that decides the safer landing of an aircraft. So, in general, the primary goal is to manage the descent rate in such a way that the aircraft can touch down safely within the designated landing area. So, this must be very cautious whether the aircraft is touching the landing area very safely, and accordingly, and to ensure that we need to design the aircraft landing system effectively. More than that, safely. Aircraft landing using fuzzy logic control. So, we can consider the two control system here. One is controlling the altitude, another one is controlling the speed. See, the altitude of the aircraft must be carefully monitored and controlled to ensure the descent gradual and within the safe limits. So, we have to ensure that the altitude of the flight while landing is very descent, that means gradual decrease, and that gradual decrease should be within the safer limits. In case if there is a rapid decrease in altitude, this may lead to a hard landing. Also, on the other hand, if it is a slow descent, then it might cause the aircraft to overshoot the runway. So, both are possible. So, we should have a balance between rapid decrease and slow descent. So, you should be very cautious when you are adjusting the or when you are trying to control the altitude. Next comes the other factor, speed control. The speed of the aircraft needs to be managed to ensure that it is neither too fast nor too slow during the landing. It will be between too fast and too slow according to the environment. So, if the speed is very high, let us take if the speed is very high, then it results in overshooting the runway. The flight may cross the runway. If it is very slow, then that aircraft, that low speed may cause the aircraft to stall. Maybe it gets stopped without moving further distance. So these are the things that one has to keep in mind to design the aircraft landing system. So we need a system that studies the parameter and that understands the uncertainty and the imprecision in the parameters, and we need to know how the safer limit can be achieved either in the terms of altitude and as well as in both in the terms of altitude as well as in the terms of a speed. So we need to quantify those values. So fuzzy logic plays a vital role in designing such kind of uncertain systems. Another parameter, distance to runway. So the distance to runway is a crucial parameter that helps in adjusting both the altitude and speed to align the aircraft properly for landing. So you need to always calculate the distance between runway, and in order to estimate the distance between runway, you need to depend on the two parameters that we have discussed in the previous slide, that is altitude and speed. So it has to be altered or it has to be adjusted in such a way that the aircraft should always ensure the proper landing. So we need an accurate distance measurement system which always make the system to calculate the needed rate of descent. So the needed rate, at what rate the distance has to be descent. So you need to think about that. So what is descent rate? The descent rate is the one which is received as the output from the fuzzy logic controller, and that fuzzy logic controller aim is to manage that descent rate, the rate at which the speed is adjusted, the rate at which the altitude is adjusted, the rate at which the distance to the runway is adjusted. So everything is need to be managed in a safer way. So the descent rate is the one that determines how quickly the aircraft loses the altitude. So it is very essential that the descent rate must be controlled. It must be properly handled in order to ensure a smooth touchdown. Touchdown. What is a touchdown? The touching of the road on the wheel of the aircraft. So both need to be properly ensured. So to design such kind of controller using fuzzy logic for landing the aircraft, so here we can understood that there are three input variables. One is altitude, another one is speed, and the third one is distance to the runway. What is the output? The output is the descent rate. So rate at which, so we need to calculate based on the altitude, based on the distance, based on the speed, distance, we need to understand. So based on that descent rate, altitude, speed and distance have been altered, right. Now each variable is represented by fuzzy sets, and the relations between these variables are described using fuzzy variable as usual and in general. So what are the input variables? Altitude, speed and distance to the runway. So altitude is measured in terms of feet. So this altitude variable is divided into three linguistics: low, medium and high. For low it is taken as 0 to 1000 feet, and for medium it is taken as 500 to 1500 feet, and for high it is taken as 1000 to 2000 feet. So if you could see that there is a overlap, here there is a overlap and here there is a overlap. So this is to ensure that uncertainty, right. Correspondingly come to the next parameter, speed. The speed is represented in terms of knots. So we have divided into three linguistics: slow, medium, fast. Slow with the range 100 to 150 knots, medium in the range 130 to 180 knots, fast in the range 160 to 280 knots. So this is the way you need to think about it. Distance to runway, it is represented in terms of nautical miles. So close, medium, far. So 0 to 1 nautical mile for close, 0.5 to 2 nautical miles for medium, and 1 to 3 nautical miles for far. So what is the output variable? The output variable is descent rate. So the descent rate is feet per minute. So we have divided into low, medium, high. 0 to 5 feet per minute, 2.5 to 7.5 feet per minute, and 5 to 10 feet per minute for low, medium, high accordingly. for the descent rate. So having understood these kind of adjustment, next thing is you need to define the fuzzy rules. So what is this fuzzy rule? The fuzzy rules define how the input variables influence the output variable. For an aircraft landing system, the rules must be: if altitude is high and the speed is fast and the distance is far, then increased rate is high. If the altitude is medium and the speed is medium and the distance is medium, then descent rate is medium. If altitude is low and the speed is slow and the distance is slow, then the descent rate is low. If the altitude is high and the speed is medium and the distance is medium, then descent rate is medium. So likewise, you have to write all such kind of rules in order to handle that system effectively, right. What is the rules? So previously the system has been designed, now the rules has been generated. Now how to design the system and followed by how to implement the system in MATLAB environment. To design a fuzzy logic control, for we have to use the MATLAB fuzzy logic toolbox, and this MATLAB fuzzy logic toolbox is having a fuzzy inference system which will design the system effectively, and we can execute and evaluate the system also. So here the first variable is Memphis, the second function that you are using is add input and add MF. So Memphis is the function that has been used to create the Mamdani inference system. Add input, adding the input variable to the input, and add MFs are meant for adding the membership function variable for all the input variables. Correspondingly you have to assign trapezoidal MF and the variables for the trapezoidal MF and the linguistic values. So as usual, the general procedure. Likewise for the speed, that is represented in the terms of knots, you have to add it by add input, and you have to divide it into linguistics by add MF. Followed by the output is distance to runway, and here you have add inputs. See, here one question may arise, since the what is that distance to runway is output, is there any variable add output? So here the inbuilt function is add input, you can treat that as the one which is meant for input variable, and I can clear you this point when I will start taking the practical session how to design this system in the MATLAB environment. And add MFs are using for this. So output variable, see the output variable, add output variable, right. So this is the case in which you need to design the input and output variable of the fuzzy logic system, and for the every case, see the every statements are repeating, similar to the other system that we have discussed so far. Rules. So in general, how many rules it has been having? It is having 9 rules. These 9 rules have been written in such a way that each rule is assigned to a variable, rule 1, rule 2, rule 3 accordingly up to rule 9, and each rule says about the relationship between the input variable as well as the output variable in the form of a conditional statement. See, if altitude is high and the speed is fast and the distance is far, then descent rate is what? So there are 3 input variables. The first variable is high, the second variable is fast, the third variable is far. So how the descent rate? The descent rate is also high. So accordingly we have 9 rules, and all these 9 rules have been added to the system using the function add rule. So now the system is ready. System is ready in terms of linguistic variables and in terms of membership function for each linguistic variables and in terms of rule. Now the major component needed for executing the fizz is ready. Now the fizz system has been executed by substituting the input 1500, that is for distance, 180 that is for speed, and 1.5 that is for, I think, what is that, third one is distance to runway. The first one is altitude, yeah. So the first altitude and speed and distance. So these 3 parameters has been given as a input. Now how this output is evaluated? The evaluated output is eval-fizz, for which how we got the output, that we can discuss in the MATLAB simulation practical session. So the practical example that can be given to you to understand that system as a system development is to better understand the practical implementation. How an aircraft is approaching a runway Assume that your aircraft is assuming a runway whose altitude is 1500 feet, speed is 180 knots and the distance is 1.5. So, in that case you have a controller in your hand. So, how you are going to adjust that controller so that the descent rate is adjusted in order to ensure a smooth landing. Now, you assume that the flight is approaching the runway. So, whose speed is 1500 altitude, speed and everything is given. So, you need to design the control. So, that is a, so input is, this is what that is given here. So, altitude 181. So, these three values are given. So, altitude 180, so fuzzy rule applied. So, which fuzzy rule has been fired? So, this also you need to understand which fuzzy rule is applied. Based on that, see this 1500 falls within the medium and 180 knots is also falls in the medium. So, since 3 are medium, see altitude is medium, speed is medium and the distance is medium, then the descent rate is also medium. Where I can find this rule and what is the number of this rule? Altitude is medium, then speed is medium. See this, if the altitude is medium, speed is medium, distance medium, then the descent rate. So, it is rule number 2, I think so. Yeah, yes, it is rule number 2. The rule number 2 is fired. Rule number 2 is fired, right. So, in the MATLAB code, if you give that the same thing has been affected. The descent rate should be set to a medium value to ensure the smooth under. So, what is the thing that you have to give? This you have to give the input and finally you got the output. So, this is what the designing of aircraft landing system using fuzzy logic. So, what is the next control system? That is designing a inverted pendulum. So, what is this inverted pendulum first of all? So, it is one of the traditional and most important classical problem in control theory. All the one who started to study the control system and never skip this problem. So, inverted pendulum is a most popular and a very essential problem in the robotics and it is to understand the theory behind the control system. The objective of this inverted pendulum is we have to balance the pendulum both in the upright position on moving a cart. You are moving a cart, but while moving a cart the balance of the pendulum should always in the upright position. So, in general when you talk about this kind of system, that is inverted pendulum system, this is inherently unstable system. So, when you want to make it stable or when you want to make it good, so it is a challenging task, it is a challenging task. So, we can go with traditional PID controller, but this PID controller is very complex and as usual it cannot handle the non-linearities and uncertainties and the vagueness present in the environment. So, you came with the fuzzy logic because it always tries to mimic the human decision making process. So, in the inverted pendulum the primary goal is to control the position and the velocity to keep up the pendulum balanced upright. So, what are the two input variables and output variables that you can see that. So, before that you can see there are two components, one is pendulum, another is cart. Say there is a cart, right, over which we have a pendulum, So, a rod that pivots around its base, a platform that moves horizontally in the barrel. So, these are the two components that is associated with the pendulum. The control system must respond to the changes in the angle of the pendulum and adjust the force applied to the cart. See, before designing any control system to a particular application, first you should thorough with the system operation. What is that inverted pendulum? Why is it used and how it is used? What is the purpose of that inverted pendulum system? How it looks like? What is the general operating principles of that pendulum? And what are the things that are needed when you are using it for a purpose and how to adjust that values associated with that and how this traditional controller is adjusting the values and what is the expectation from the facility. So, every fundamental idea that you should be thorough with the standard operation of the any system. The inverted pendulum is also one such system that need to be studied very clearly. So, while you are understanding or while you are trying to understanding the components and its operation of inverted pendulum, it is very widely understood that the key variables in the system are angle, angular velocity, cart position and cart velocity. So, these are the things. So, what is angle? It is the angle between the pendulum and the vertical axis. What is the angular velocity? It is the rate of change of the angle. What is cart position? The horizontal position of the cart. What is cart velocity? The rate of change of position of the cart. So there is a cart for which you have a position and a velocity. The cart is also moving, and there is a pendulum over which, for which you need an angle. The pendulum will move like here and there, like here and there. So you need to change the angular velocity, and at each angular velocity, what is the angle there? Pendulum. So the physiologic control for this inverted pendulum has two input variable. What is the input variable? Angle and angular. Let us take for this example, for which the force applied to the cart. So based on the angle and angular velocity, what is the output we got? The force that has been applied to the cart. So now you start the idea of designing the inverted pendulum system using the physiologic control. So what is the first step? The first step is defining the input variables and membership function. Let us take the first input variable, angle theta. Since it is the adjustment of the angle, so we may divide these linguistics, say for example, into 5: negative large, negative small, 0, positive small, positive large, like that. If it is negative large means what is that? The pendulum is leaning far to the left, it is leaning far to the left. If it is negative small, it is slightly leaning to the left. So if you could imagine that this is the pendulum, so you may treat this left and right. So left is, if it is very fast to the left, negative large, if it is smaller, negative small. So like that, 0, pendulum is upright, pendulum is upright, it is totally upright, the pendulum is. So accordingly the pendulum is leaning rightly, slightly right, and the positive large is leaning. So you need to understand the idea of the operation of the inverted pendulum. Angular velocity. So the angular velocity is the one that has been designed as pendulum is rotating quickly to the left, pendulum is rotating slowly to the left, pendulum is not rotating. So these are all the variables that you can understand from the way in which the inverted pendulum is operating to control the system. So the next to the idea of understanding the variable, then you need to understand about what are the membership function, that is tri-MF, right? Triangular membership function, tri-MF, tri-MF. And for this tri-MF, the first three values are minus 30, 15, 10, 0 for NL, negative large, and for NS. So for all the variables, the values are taken in such a way that the values has been utilized in order to bring the uncertainties as well as the non-linearities that has to be present in the system. So right, angular, likewise for angular velocity, tri-MF for all the variables, and for force NL for all the variables. So if you could see that the variables are like this: for negative large, negative medium, and 0, and positive small, and positive large. This is NL, NS, 0, PS, PL. So the variables are looking like this form, and accordingly the input variable range is there, but this is always 0 to 1 because this is going to be universe of discourse, and this is the corresponding variable name A, for example angular velocity or force F, like that it has been changing, right? Fuzzy rules. So now having designed all the membership function values, now it is the time to think about how to define the control rules. So as I said, the control rules are the one which is represented in the form of a if then statement that has been derived from the expert in general, but over the period of time expert opinion or expert writing all possible rules by exploring all the various problematic situation is highly impossible. So either you can go for optimization based approach or a data centric approach. So the fuzzy rules define how the input variables angle and angular velocity influence the output. So that is the relationship between angle and angular velocity, how it is defined. If theta is NL and the theta is NL, so what is the F? That means force. So the rules has been written like this. The rules are written like this, and you have to design the rules. So how to design the system? So as usual, the design the system can be physiologic MATLAB toolbox, where you can define the input and output variables in terms of membership function and fuzzy rules. So what are the functions available? As I said, Mamdani inference system, add Memphis for designing the system, and add input for reading the input variable, and MF maybe dividing the input variable into linguistics, and another input variable add and their corresponding add mf, and the third add output, that is the output variable and their corresponding mf. So everything has been written meticulously. Either you can go with GUI mode of development or you can go with code mode. So if it is code mode, you have to write code accordingly. If it is right mode, then you can do the plug and play operation that we can discuss in the MATLAB session. So the define the rules. The rules are defined. See, the rules defined is something different here, right? See what rule list, we have created a matrix rule list. So we have created a list and we can 1 1 5 1 1. We may say that. So that is negative large, negative small, 0, positive small, positive large, right. This negative small is what is that? Low, medium, high, like that and all. So accordingly you have to take, accordingly you have to take. So this is the way you need to understand the rule list. This is the rule one. Let me explain that one. What is that first rule? The first rule is theta is NL and then FL is. So accordingly you need to design this rule systems NL, LL, LL, like that, right? Right. The initial angle we have designed, the omega, everything is designed for the initial condition in order to check the inverted pendulum operations in the MATLAB coding environment, and followed by you need to evaluate the FIS systems, the eval FIS, see, in order to understand the values. Now you can update the angular velocity and angle. So we have to check whether the pendulum is in the safer positions, when we moving the cart, always it maintain the stable equilibrium or not. So we need to check the system by means of the code. So finally, how to display the results for all each and every values of this, you can say how the values are defined and how the values are varied with respect to all the parameters, right. So when you pick up that, so the membership function is for all the cases a triangular membership function is created and the rule matrix is created in the form of a matrix. So the execution is carried out for 100 times, finally the result is displayed in the form of a table. So this is the code that has been meant for designing the inverted pendulum system. Of course we will see in the practical session how this code has been implemented and how the code has been written in the MATLAB environment. So this session we have discussed about two, one is aircraft landing and inverted pendulum. So aircraft landing is a general problem of the control system that we have used 2 to 3 variables as an input variable and one output variable as an output variable. But here in terms of inverted pendulum, here it is a continuous process of testing the system. So the code is little different when you compared with the aircraft landing, apart from designing the rules, MF. So rather than simply executing the system, you need to check the system operations over the period of iterations and then you have to tabulate the values. All these things can be very clear when these code and all can be started implementing in the MATLAB environment. Thank you.